Right then, so following right on from last time, we managed to create an index meta method for our for each type that we registered. So we created a meta table with an index meta method, which just called this index user datum C function, and we got that to actually invoke functions that were called in Lua script on our type, which was like this. So we had our sprite.draw, or sprite draw, I should say, and that was pretty cool. But we didn't handle any of the input parameters, and we didn't handle the return values from those functions, and we left ourselves with a bunch of to-dos here. To do, we need to pass parameters to native methods, and to do, we need to handle return values. And these are actually going to be a bit easier than we thought, because what we're going to do is, if you haven't seen them, you have to go back to video 23 and 24 in this series, where we actually set up this function up here, which is, this is able to call a global function that we registered. So not a class member function, just a normal global function. But this can, like, at least in a limited way, it can accept some number parameters, and it can return, you can see it returns ints and shorts, and it's able to do that. The good thing here is that this code is almost exactly what we want to call class member functions as well. The only difference, I believe, because it starts with a method that we want to invoke here. We get the parameters, we check all the parameters are correct. We're collecting the pass by value parameters, we're building up an array of them. We then invoke the method, and the only difference is that when we call global, we just don't have an instance object to call the function on. So we just pass in this initialized, like empty initialized instance to just signify that this is just a free function. It doesn't have an object that we call it on. And then we collect the return values. So that's all embedded just in our core global function. But if we just passed in the actual, whatever this is, an RTT instance object, if we just passed in that, this is pretty much exactly what we want. So this video is just going to be a bunch of refactoring, really, to get that to work. So I'll refactor that out, make sure call global still works, and then we'll replace the invoke that we've got here with that, and we'll pass in our instance object. You can see it there, and hopefully that should sort out all our problems. So let's just check that we've got. So yeah, to do, need to pass native parameters. So we've still just got exactly what we had before. So we'll start by refactoring this. So really, we want to take all of this code, the whole lot, up to. So this is, we want absolutely everything except the method to invoke, which we're going to pass in. So let's take that and let's put it in its own function. I'm just going to call it, I'm going to call it invoke. I'll just call it invoke method. So we'll paste that in there. It's returning the number of values that we're leaving on the Lua stack. So yeah, I'm returning it in there. We're going to need the Lua state in there, definitely. Can't spell, but yeah, we're going to need it. So we need that. Let's just call this in here to make sure everything's back the way it was. So the idea with refactoring is that we're trying to change the program, but at the end of it is nothing behaves any differently. So we're just restructuring the code. We're not changing the behavior of the program. So the first part of the refactoring is to get this to carry on working exactly the way it was, just in the call global. And then we'll see if we can call it again in the class version of it. So we want to invoke the method, we want the Lua state, and we also need to pass in the method to invoke. And in our case here, we don't have an instance or anything, so we're just going to pass in nothing there. So in here, this was an RTTR method, I believe, and it's called, I'll pass it in as a reference, I think. I'm not sure if that's the right thing to do, but yeah, probably. So that should carry on working as before, I think. Yep. So yeah, so we're still, these are our native, our global functions being called here, hello world 2, and there's the one with the parameters. And that part's still broken, but nothing's really changed there. So that's exactly what we wanted. We've refactored out part of the code out of call global from Lua into this invoke method function, and we've passed in the method to invoke. So really what we want to do now is we want to call that in our this is that invoke function on user datum. So this is like invoking our class method, and really what happens now is we don't need, well, that's just an error. We're going to invoke from our new method. The return type is handled by that method as well, and that's an error about the return type. So all that goes away. In fact, so does that, because we can actually return our value, and this all gets replaced with do we have the method to invoke on this, which is, yeah, we do, which is m here. So we have the method to invoke, but we also want to pass in our, well, it wants an RTTR instance. So let's make one of those. So this is our object that we're going to call the method on. And I think we can pass in that and create one of those. So ideally that's what we want. That's what we want to happen with that one. And of course, the other one, well, it's complaining because we haven't defined that parameter yet. So let's define that first. Let's pass in an RTTR instance into this function here. Let's just call it instance. Let's call it object just so we don't get confused. Let's see what doesn't compile there. So this one now doesn't take 2 arguments. So this one needs the original thing which it had, which is the it needs an object which is just, I think that's what it was originally, just a default initialized object, and that's just a way of saying this is just a global. So that should, will that compile? Invoke function user must return a value. So I need to return that. This function is returning the number of values on the stack. So it's kind of replacing what we've got here. So that should put the stuff up, put the return value on the Lua stack, and then just tell me how many it was. So I can just return that from this function, because that's what this function wants to know. How many things have I left on the stack? So that has apparently worked correctly, but I'm not sure if that should be, because we haven't used this object. So it's not complained about that, but that should be passed in there in our invoke variadic. So this is now, this should now carry on working as before, I think. Except it hasn't. So actually the global functions still work, but we're invoking it with our as a class method, and it's gone wrong because error calling native function draw wrong number of args, expected 0, got 1. So it's trying to invoke the draw function on our sprite, which is that, which does have 0 arguments, but it got 1. So I think we've made some assumption that that function makes some assumption about what's on the stack, and that doesn't work in this case. So let's have a look at that. So where is it? Invoke method. So what we're doing is we're asking the method how many parameters do you have, which is the number of native args, and then we're getting the top of the Lua stack. And when this is a free function, the top of the Lua stack would be the number of arguments on the stack, because it'd just be if the top of the stack was 3, it's 1, 2, and 3 are the number of arguments, are the arguments on the Lua stack. So that would be correct. But when we're calling a class function, that doesn't work, because at the top of the stack, or sorry, at the bottom of the stack, we've actually got the user datum, which is the object we're calling it on, and then maybe our 3 functions would follow. So we'd actually get 1 extra. So I think that's what's happening there. Yeah, so it's supposed to be 0, but it actually got 1, because that's the user datum, which is the, like when you think about it, a class member is actually, in this case, it's actually a function with 1 argument. The argument is the object you're calling it on. Just like the way all these Lua functions that we call, actually the first parameter is just the Lua state. They've always got one extra parameter. So we probably just need to account for that in this function just to get it to work in both cases. So maybe the best way to do that is we'll make the assumption that the top of the stack and downwards is the parameters that are being called. So we're not going to assume that there's the exact number of parameters on the stack. We'll just say you can pass me 1,000 parameters if you want, as long as the last 3 are the 3 that I need to call this, or the last 2 are the 2 that I need to call this. So it doesn't matter. So then we can leave whatever we want on the stack, and the top of the stack is the parameters, because that's the way it's going to get called anyway. So I'll just flip those round. So what we'll do is we'll say number of native args, that stays the same. The number of Lua args is the top, and if the number of Lua args is greater than the number of native args, so that would be the case where we've probably got our object on the stack because we're calling a class function. We'll just say the number of Lua args is actually the number of native args, so we'll just cap it to that correct number. And will that work? I mean, I think that might work. Well, at least that sets the number of Lua args correctly, but that appears to have worked. What has it done? Sprite 00. Actually, yeah, it looks like that's worked, but actually we're not calling a function that has any parameters on it. So let's try that. So I think we've got a move function. Yeah, I was surprised that worked before. Yeah, because we're not actually calling it. So we've got a move function that's got 2 parameters. So let's move it to 1. Well, let's move it to 42 and 43. And let's see what we get this time. I think this should break. Oh, there we go. Assertion failed, line 70. So we were previously doing a search. We probably change these out for Lua errors. Line 70, what have we got? Don't know this type. So I think what's happened is we've messed up these types because I think we're reading from the wrong place. Yeah, we're reading from the bottom of the stack and upwards, and that's wrong in the case of the native function because there's stuff on the bottom of the stack. There's like our native object call is actually sitting there on the bottom of the stack. So we probably need to offset that, but let's just fix this assert first. Let's change this out for a Lua error. Just see if we can get any better information about that. Don't know this type. So it's a Lua type that's wrong here. And what is it? That's the type. There's a function to get the name of a type in Lua, which is handy for debugging and stuff. Yeah, Lua type name. You just pass it the type, the index of the type, and it should just give you a name for that, like nil or table or whatever. So is that correct? To Lua state, Lua. What is wrong with that? Why does it think that is a? Why does it think that is a? Is it type name I want? It is type name. I think I've got the wrong function here. Is it to type name? It's actually, I think it's Lua type name. Oh, hang on a minute. I've got the, oh, no, I know I've got it wrong. It's because that needs a Lua state. That's a total mess. That would really confuse me then, because I was like, why is this Lua type name wrong? And it's not. I thought I'd got the wrong function. Let's try that again. So don't know Lua type user data. So actually that probably makes some sense now, because we haven't handled user data as a parameter yet, and it looks like we were expecting numbers here, but we've actually read the wrong value. It looks like we've read the first value off the stack, which is a user data. Then there's a couple of numbers. So we need to start at the first number and work our way down. Let's just add a bit more error to this while we're here. It's parameter I, so that's like the number of the parameter that we're processing in the function call when calling, and I think we can get the name. Can we get the name of this? Yeah, that's the name of the function we're invoking. I'm just trying to get a bit better error information in case this goes wrong in the future, and then we'll have, like, we won't be sitting here for hours going, what the hell happened? So don't know this Lua type user data parameter 0 when calling move. So we'll leave that like that for now. That's a reasonably good error message. And so what we need to do really is just, I think it's this, what we're doing here is we're looping round the number of arguments that we're going to read off the Lua stack. We're starting, this loop's going from 0 to the number of args. So it would start there 0. We add 1 because Lua indexes everything from 1, but we also need another offset to say where it is we're going to be starting. So probably call that, just call that Lua params stack offset. So we just push that up a bit more to where it's going to be. That would be, I'll set that up here. That would initially be 0, and that's fine for the global case, so the free function case, because that's exactly how we called it before. It just didn't have any offset. But in the case where the number of Lua args is greater than the number of args, that's when we need the offset to be correct. So this offset needs to be, it's going to be the number of Lua args minus the number of native args. So all we're saying is that however many extra parameters there are on the stack, just push forward by that many. We're just going to read from a certain point in the Lua stack to the top, and that's where our parameters are. So there's only 3 parameters. We want to read just those last 3. So that should offset us to the right position, should get us the right Lua arg, and hopefully that fixes both the global free function case and the method call case. And it looks like it has. So we're still calling our global functions, and our sprite there has been moved to 42, 43. So that is all we need to do. We've basically done a bunch of refactoring there to get some code that we wrote before to just work in this other case, and with not much changing in there. And that's really good, because it was quite a lot of work to get this to work. And also we're going to need to come back and refactor this, because it doesn't handle all the cases and not all the return types are handled down here. So that's going to need refactoring. So we definitely only want one of those. We don't want to like copy and paste code or anything like that. So the fact that we've got one function that we can invoke when we're doing free functions or class methods is really cool. And you can see there's not much difference between them. There isn't really, when C++ gets compiled, there isn't a great deal of difference under the hood of how those C functions and the C++ ones are being called. They've just got an extra parameter, and you can see that's been our whole problem here. And I think the code actually looks a bit cleaner as well. Call global from Lua, you can see this is really cool now. This is just like get an up value, which is the method, set an instance object which doesn't exist, and then invoke that method with that object, and this thing will just pick up all the stuff. And same thing down here, we can get rid of all this now. Same thing down here, except the instance object is actually our variant that we pulled off the stack. So all we should probably do before we finish, because that's basically done now, is just maybe put some, we should just put some comments on this, because this is now, this function is now expects some things to happen. So that's the kind of stuff that it's not really, you can really see if you just if you're just looking at that. You'd have to read through the code each time to try and find out what this is. So what this actually does is it will invoke method to invoke on object, and passing the arguments to the method from Lua, and so that's what we're going to do. So this function will invoke a method on an object that we've passed in, and we are passing the arguments to the method from Lua on the stack, and we're leaving the results on the stack. So what else do we need to know about this? Return the number of values left on the stack. So that's a pretty standard thing for other Lua functions. In this case, this is one of our functions, but it's still doing the same thing. And what assumptions does this make? Assumes that the top of the stack downwards is filled with the parameters to the method we are invoking. And what else do we need to know? To call a free function, pass as object. So there you go. So there's just probably just a bit of information on how we call this and what it's actually doing. But this is a really good function to have, because this is probably where most of the work's going to be, is just expanding this function, getting it to call stuff, doing error checking in here, working out how we're passing by value and all sort of stuff, working out how to put stuff on the stack. And then it's made our code much cleaner, much easier to read. And that's all pretty cool. So let's just test that we can call this a few times before we call it a day there. So actually we need to test that it returns values. So let's have move return, let's just have it return the x plus the y value. And I think the good thing about this is if I just change this function now, that's it. I think that's all I need to do. So the function changed. The registration didn't need to change because you don't actually have to pass in any parameters or anything here. It just knows how to do it. And now we can just use that in here. So now this returns a value. I don't want to call it sprite. So local x plus y is that, and just for kicks we'll just pass that in again. Actually, let's put smaller values in here so we can see what's going on. So 1 plus 2 is 3. I can do that. So it should move to 3, and then it'll move to 3 along, and should move it again by 3. So it'll go from 0, 0 to 1, 2. Then we should get 3 as the return result. We'll go from 1 plus 3, so we should go to 4. We should go to 4 and 5 when it draws. Let's just check that works. This is where we find out it's all broken. 4 and 5, there we go. So sprite moved to 4 and 5. So you can see that the return value stuff that we wrote for this global stuff is working just the same when we're calling it with these class members. So that's all really good. Next time we still have I think we still have a to do in here, or did we take it out? No, there's our to do. We need to check to see. So if we didn't manage to invoke a function, we need to check to see if the thing we're trying to do is actually a property. So that would be for the next time. And it will be able to put some Lua code in that will cause that error to happen. But for now, that's really good. That was just a bunch of refactoring that for code that we wrote before. It's like free work, and we managed to get parameters and return types to start working on our code. So that's really cool.